when I was asked to do this, it's a sort of a real, I've been asked to do something grown up. What am I going to do? I won't be able to swear. Got to keep me cool. Can't go on about how bad Nottingham is compared to Derby. So what I'm trying to do today is to take you on a whistle-stop tour, something that's quite close to us as a business. But where does sustainable technology take us, and where's it come from? Bit of a surprise. We talk about this topic with a little bit of authority because I'm the CEO and owner and founder of BMW Technology Group, and primarily we're a composite component manufacturing business. We're actually a high-performance engineering business, and we make things lighter, we make things faster, and we make things perform right at the edge of their parameters. This is our technology centre in Derby. And we're pretty much embedded in Formula One, particularly, one of the key suppliers into that market, certainly one of the largest composite companies supplying into that market. But we're also involved in aerospace and defence, aerospace, automotive and defence. Today I want to take you on a journey from where I see Formula One and the impact that's had on all of our lives, because I do think as a sport we miss it. So I'm talking about sustainable technology from unexpected sources. So the revolution began in 1981 in my mind. McLaren, Formula One, having a go, trying to be world champions, turned up at a race where everybody else in the paddock had aluminium chassis. And they turned up with a carbon fibre chassis. Scrutineers looked at it and went, ooh. The drivers looked at it and said, is it safe? And they said, we don't know. But they got in anyway, because it was certainly going to be safer than the aluminium ones. But this is a revolution, without shadow of a doubt. But it took 5-6 years to get there. So in 1986, what were we learning? We were learning that things had to go really quickly. We were learning that a composite chassis structure could be lighter, could be safer, could add to our performance. But we're also learning about lubricants. We were learning about aerodynamics. We were learning about all sorts of crazy things, and we were learning them really quickly. So what are we learning in 2016? Well, we're learning about KERS. We're learning about fuel efficiency. We're learning about huge amounts of power coming out of little engines. But we're also looking at the composite structures now, and we're saving drivers' lives. Particularly Alonso at the first race this year took a 48G impact. Now, strangely, none of the safety systems on the vehicle actually got into serious activity. He survived it anyway. By the sheer fluke of all flukes, the car flew into the air and it brushed everything, so nothing crushed particularly, nothing crumpled like it was engineered to do, but yet he still survived. Incredible engineering. But running alongside this, you've got active aerodynamics. You're doing things with the wind. You're making parts lighter, stronger, and faster. And it's happening very quickly. So what will we learn from these things in the future? Because the world is moving. We're going at a hell of a pace. And it's just getting faster and faster and faster. Well, we certainly know things need to be lightweight. Thank goodness for that, because that means my business plan is bang on agenda. But we also need to know about batteries, and we need to know about how things are going to be driven, and electricity, how we're going to use that efficiently, and how we're going to capture it, and then how we're going to use it. We also need to be super efficient. When you consider a Formula One engine now as a 1.6 litre only V6 engine, and yet it does the whole Grand Prix with 100 litres of fuel. Now, in the past, that would take you to 20 to maybe 25 laps, and they'd all come in a bit of a panic, put more fuel in, and out you go. But now these cars are twice, if not 3 times more efficient, and yet they're going faster with smaller engines. Incredible. So we've got to learn how to be super efficient. Aerodynamics plays its part, engines play its part, lubricants play its part, so does the fuel that they actually put in. And we've also got to start thinking about supercharging. How are we going to go really, really quickly? But how far away is this? BMW Technology pioneers have already put it in the high street. Carbon fibre structure with an aluminium battery pack. Sign your life away and you can be the proud owner. But what about technology demonstrators? The pioneers behind this that are taking the tech and taking the risk to put that into the road. Active aerodynamics, super fast engines, KERS, energy recovery, all in one little package, yours for £500,000. But it is available in some way, shape or form. Renault, owning Nissan, have given us a platform that's now proven. You can buy a car, its architecture is pretty much normal, and you plug it in. Weird. But you charge them up. No engine. But it's proven technology, and it's getting better and better. And then the whole crazy world of computer companies is going to have a go at making a car autonomous, self-driving. How is that going to work? Incredible tech that's coming really, really quickly. Be interesting to see if Mercedes have a go at a phone or a computer. So change, how far are we prepared to go for this competitive advantage? In 1986, when McLaren were pioneering and really driving for the championship, we were in great big aluminium super efficient structures. Never before have we travelled the world carrying so many people so inefficiently as that. But it's a super efficient structure in its day, all aluminium. Again, thank goodness, because this is bang on with our business model. Aeroplanes are becoming carbon fibre. So they're advanced lightweight structures. They're environmental game changers. They're technology hungry animals that have to keep us safe when we're flying. So from the glitz, the glam, the allure of this sport and the drive to be competitive, where's it all going? What is going to happen next? Well, BMW have an idea. This is the next 100 years, their concept. And it's intelligent architecture, intelligent vehicles. Things are going to be doing things very, very differently. Aircraft, super intelligent structures. The more vigilant of you will notice the engines are not on the wings. So these wings will have sensors in them, and they will move and they will flex with the conditions of the air they're flying in. And maybe even the engines, not great news for Rolls-Royce today, but they could be electric in the future, or it could all be sat in little nuclear fusion things. Super intelligent, efficient things that are changing the world. And then autonomous racing, coming all the way back to racing. Motorsport historically, which is brilliant for the UK, it's a £3 billion business employing some of the brightest people in the country. Intelligent engine technology embedded in an autonomous racing car. No Lewis Hamilton crashing into Nico Rosberg here. And why are we so proud of this? My business has won the contract to make this, a multi-million-pound 5-year contract, pioneering where this technology is going to go. And F1 still got to play its part. The teams are itching to go. It's the rule books that are holding them back right now. So these Formula One cars of the future, they're going to be intelligent, they're going to be game changers, they're going to have engines like we've never seen before, and they'll have aerodynamics doing all kinds of crazy stuff. Why? They've got the money, they've got the budget, and the rule book brings that innovation incredibly quickly. So the drive for competition, Alain Prost versus Ayrton Senna, all those years ago, has it really driven all this tech and all this innovation from a very unexpected source? It certainly has. Thank you very much.